And work on that. And so let me share my screen right quick. And I gotta find it too, because I know I sent it to myself. Check my email right quick, hold up. Yeah. Oh, all right. So this is like the last problem set, and it's basically focusing on like the last set of information that we've covered. So the first question is from kind of similar to FK 506, and it asks to provide the reagents for step 1 and predict the product at the end of the reaction sequence. So the reagents here for step 1 would be how to convert this alkyne into a vinyl bromide, right? So and you also have a methyl group here. All right, so that's the first part of the problem. And the second part is how to take what happens if you take the vinyl bromide and then treat it with tert-butyllithium followed by this aldehyde right here. Like, what would you get? And that's going to also include some stereochemistry as well. So that's the first problem. And then I can add a page so we can kind of work through it. Second problem is how would you make this from cyclohexanone? And then the third problem is how to synthesize compound 2. And then here it says provide a reaction sequence that will convert 3 to alkene 4 in a stereoselective manner. So we kind of talked about this a little bit. I think it was either Friday or Wednesday when we were doing those. I think it was the N heterocyclic carbenes, where you can actually get these alpha beta, like these unsaturated type of systems, like pretty quickly. But you can also think about this a lot of different ways. But let's start with number 1. Let's start here. Let me erase all that. And I'm gonna copy that and paste it on a blank sheet so we have some room to work. Copy that. I'm trying to see how to landscape it. There we go. Oop. No, never mind. All right. Crop this little top piece off. All right. So let's look at that first, the very first step, and think about how we would do that. And we talked about like alkynes and how to convert them into vinyl halides, as well as converting them into substituted vinyl halides. So what method, if you jog your memory back, what method can you think of where we could possibly pull this off, starting with that alkyne? I'm thinking of it now. It was something that we talked about when we were talking about alkenes. And one in that last section, we started talking about alkynes, and I think there's a method that we talked about there where you could actually pull this off in one step. We're trying to take the triple bond here and convert it into that. All right, let me see if I can find that page of notes. Let's see. Yeah, I think it was. That's not the note, but I think it's somewhere in there. Let me see. Yeah, so when we did hydroboration of alkynes, y'all remember doing that? I think one of those methods allowed us to transfer an alkyl group. Or maybe not. Okay, never mind. I know you could transfer an alkyl group, but it doesn't keep the halogen. So we got to come up with a different way. All right, so when we think about the alkyne itself, like think about the fact that the alkyne is that proton is base labile. Right, so you can treat that with butyllithium and get the acetylide anion lithiated, so we can get this. And then the alkyne is going to be here. But it's now lithiated. So with that in hand, you can easily add that methyl group in with no problem, right? You can add that methyl group in, just adding in like methyl iodide or some other like a methyl electrophile. So if you treat that with methyl iodide, it's going to give you cheat right quick. It's going to give you this with a methyl group attached. Now we need to think about how to make the vinyl bromide. So now we need to think about how to add a bromine to that carbon. What do you think? We could, I mean, we already talked about some methods before, but what do you think? What would you do to convert that to the vinyl bromide?
Interior, garage, door.
Right? Think about what something that we've already done, like you can do could you do a hydrozirconation? And then convert it to the vinyl bromide? Could you do that?
Um,
All right, could you do that? Treat it with the CP2 zirconium hydrochloride, and then after that, just add in bromine, right? Because that's going to give you what is the first set of reagents going to give you? The hydrozirconation. If you do that on a triple bond.
Does it give you an alkene?
Yeah, it'll give you a vinyl zirconocene, right? You're going to get this. Whereas zirconium, right, is there. And then the methyl group will be here. And then you can take that vinyl zirconocene and treat it with bromine to convert it to the bromide. Like so, right? So you have, so that first part would be, step one would be 3 steps, right? Butyllithium, and then so it'd be 1, treated with butyllithium. 2 would be treated with methyl iodide, and then 3 would be hydrozirconation followed by bromine, and that'll get you to that molecule, right? With that, because the stereochemistry is already set at the alkyne, right? So what about the second step? What about the addition of the tertbutyllithium to the vinyl bromide? What is that going to do? Right, think about this, what we just did with the first part with N-butyllithium and the alkyne, right? Because remember we said that your vinyl halides are intermediates, right? You can use them for a lot of different things. So what do you think that first step is going to do to your vinyl halide? Because that's what you're starting with. So tertbutyllithium is a source of, it's a strong base, right? But it's also a source of lithium as well. And if you got a vinyl bromide present, it's going to convert that into the vinyl lithium. Let me move this over to here. So that's for that. That's to get there. Right. So that is going to give you, let me cut this out. So after that first step with tertbutyllithium is going to give you this. Let me see if I can work some magic. Right, that lithium is actually going to be here. You're going to convert that into a final lithium, powerful intermediate, and it's going to act as a nucleophile. That vinyl lithium is going to be a nucleophile to react with this. So we're going to take those two and put them together. What do you think is going to happen? What functional group in here is going to be electrophilic and be able to react with that nucleophile? right? Out of all the functional groups that are present. What do you think? Right. So none of this other stuff is reactive, right? The ring, the furan ring is not reactive. Obviously, the protected alcohols are not going to be reactive. But this aldehyde right here is going to be reactive. Right. So when you take those two pieces, let's see if I can work some more magic. And react them together, this is your nucleophile. So your aldehyde right here is going to be electrophilic. So when you put those together, that's where the reaction is going to happen, right? That's the whole purpose of having that aldehyde hanging out there. So we're going to do this. Let me see which one I had last. I'll keep that. Right, but here, instead of that's probably wedged. Uh-oh. So we're gonna put a wedge line here because of this, the stereocenters that's already there. Remember when that with that FK506, a lot of that chemistry was didn't have to use asymmetric catalysts and things like that because your stereochemistry was already kind of built in. So that's going to be the resulting alcohol from that is going to be wedged and not dashed. All right, so that's going to be an OH. And then that carbonyl carbon is going to have been attacked by, let's see if I can cheat. Never mind. I'll just draw it. So that's going to have been attacked by that vinyl lithium. So you're going to have this. Like that. And that is OME. Right? So that will be your final product from that. That's the fragment that section is dealing with building up. Right. And again, in order to get to that, you actually have to first start out with that alkyne. And then from the alkyne, you convert that into the vinyl bromide and then add the methyl group in first and then convert it to the vinyl bromide. All right. Questions about that? Like, so that's kind of really that question actually builds on a lot of stuff that we've already discussed, right? Of use of alkynes, converting them into other functional groups, and then using those alkynes as in coupling right? But this would be like a more similar to an aldol reaction in the coupling. But yeah, that's a way to build up that type of functionality pretty quickly. All right, questions? Any questions about that?
No, sir.
All right, let's look at the, so let's look at this question right here, number 2. Let's see if we can build off what we just did, because I think this is a great way to do that. How would we make 2? This piece, this thing right here. When you think about synthesis, you have to kind of think about, you got to think backwards and look at where you could break bonds and put things together, right? So you can see right here, a lot of times if you have just a free alcohol kind of sitting there between functional groups, a lot of times you can think of that, the precursor to that being like an aldehyde, or if it's a tertiary alcohol like a ketone. But here, if we were to think backwards, what if I broke this into, if I just broke that right there, right? And let me, I gotta cut it and then we can discuss it, because I don't want to run out of room. Let's take, I'll get rid of that too. Like when you're doing synthesis problems, you always think about like the immediate precursor to the product that you're looking at. All right, so let me paste that. All right, so if we thought about this, if we were to do a retrosynthesis, right, we could think about cracking it right there. And from there, right, let's think about that. Plus that, right? If you take those 2 fragments and put them together, you're going to get this. Right. Now, the question is, where does this fragment come from? And then where does that come from? Is that a commercially available aldehyde? Would it be in cis like that? I think it's like crotonaldehyde. Can somebody look that up? Google that. Cis. Is it 1, 2, 3, 1, 2, 3, 4? Yeah, I think it would be crotonaldehyde, cis crotonaldehyde. See if that's commercially available.
Yes.
Okay. So we could start with that, right? This is commercially available. And that's another thing. If you remember from that FK 506 molecule, the initial start material was something commercially available. I think it was Arbitol or something like it was some type of sugar derivative. It was commercially available. So that's commercially available. So we don't have to buy that. I mean, we don't have to make it. We could just buy it, right? But what about the vinyl lithium? Where's that going to come from? Right? That's why we worked that first problem first, because you could think of using a similar strategy right there, right? So how would you get to that vinyl lithium? All right, just think back to what we just did. What would you do? Could you start with a triple bond that was substituted already? Could you start with this? With a methyl group already on it?
I think you can start with that.
Yeah. Then we have that up here. We didn't start with it, but we got to it. And then we were able to eventually convert that into a vinyl lithium, because again, what you can do with that is like an aldol type to the aldehyde, right? Because those vinyl lithiums are great nucleophiles. So we could start with something like that, and then do what to it to get to here. What would we do to that to get to the final lithium? When we do the same thing, hydroxygenation, and then add in some bromine, and then add in like a lithium source. Wouldn't that get me back to that?
Yeah, it would.
Yeah, that's the same thing we just did up top. So for that total, so for this molecule, for the total synthesis of it, you would start out with this. And this is, hold up, get my mind right and my drawings. I know the people on YouTube think I'm crazy. All right, so that, and then first you want to do hydroxygenation, followed by bromine, and then lithium, and then cis-chloraldehyde. Those three things, or those three steps, will get you to that molecule. Let me erase that line. All right. And any questions about that? Right. I mean, that's when you're doing synthesis stuff. The idea, if you notice, when we did that FK 506 synthesis, they started out with the whole molecule, the macrocycle. But then what you do is you look for places in that molecule that where you could look for bonds that you could break. And those bonds that you break, you have to have a method for forming them. So that's why you break them, because I know if I break this bond, I can do this type of coupling and that'll put that in place. Or I can do this type of reaction and that'll put this in place. So that's what you're looking at when you have a molecule like this. And you have to think about how to make it. Your retrosynthesis is always what is the immediate precursor to what I'm looking at. So for that molecule, the immediate precursor would have been the aldehyde plus some type of vinyl nucleophile. And then from those precursors, the next question you have to ask is, okay, how do I get to these? Can I buy them or do I have to make them? Right? So in this case, you could buy the crotonaldehyde, but the vinyl, that's not commercially available. So you have to make that. So that's why it's important to remember like all these different methods that are available, right? And it's case by case, because some molecules are going to require, different types of reactions. So let's look at which one y'all want to do, 2 or 4? We already did 1 and 3.
We can do 4.
4. All right. So 4 says provide a reaction. See, we might be able to use that under provide a reaction sequence that will convert 3 to alkene 4 in a stereoselective manner. All right. So look at what we're trying to do. We start out with this illet. So we know that something is in there is going to be we're going to have to do acidic reaction using that illite with some aldehyde. Now, when we look at what we made, right, this carbon right here is the carbon of the illite, right? So that's this carbon right here. So it's that carbon that's either going to be bound to an aldehyde, not bound to it, but that's going to react with the aldehyde or ketone, right? Or bound to something here on this side. All right. So let's think about that. Let's think about how we want to approach that. Do we want to approach it from here, bringing that piece in, or do we want to approach it from here? All right, we started out with the illite, and so we got to think about which piece we want to add in first. And you can also see there's some stereochemistry set here. So when you think about that, let's think about it. What would you add to that illite to get to here? Let me just draw in the. Hold up, I gotta pick a different pen. What would you add to the illite to get to here? Uh-oh. Like that.
Ketone with 2 methyl groups.
Okay, great. So acetone. You could potentially think about adding in acetone. Is that right?
Right.
Mm-hmm. So if you have that, now we need to start thinking about how we can put that piece together with this piece. Right? So again, if I wanted to, what if I wanted, so let's say I wanted to use that as either do a coupling reaction or do some type of substitution reaction. Because coupling wise, the vinyl part is fine. But if I'm going to couple this side with something, I need to have some kind of leaving group here, a functional group on that vinyl part. And that's going to be difficult to do. Plus, you can see right away, I need to reduce it, right? Because there's not a vinyl group in the final product. But if let me give you a pitfall. Like, so let's say I have a method to add like a triflate or bromine here, and then I add in I couple in the other piece, and then I try to do a reduction, like a hydrogenation. What do you think is going to happen? So let's piece hydrogenate this asymmetrically in order to give me that final product. So H2 and then some transition metal, let's say palladium and a ligand. What do you think is going to happen if I try to selectively hydrogenate that piece over the other alkene? You think I'll be able to do that?
Probably not. It might be random.
Yeah, and then you're probably going to end up hydrogenating both of your alkenes, right? So that's why you have to think about. That's why you have to think about, like, okay, what do I want to do first, right? So in order to do that, what we could probably do, let's get rid of all that, is do I want to convert that into like a let's put an iodide on this carbon. Right, think back to organic 1. What can you do to put an iodine on that carbon? Right, under normal circumstances, you could add like HI HBr. What's the problem with that method though? If I add HBr, where's my bromine gonna end up? Is it gonna be on the carbon I want, or is it gonna be on the other carbon?
No, I think it'll be on the other carbon.
It will be, because it's more carbon, it's gonna follow more carbon cost rule.
Mhm.
But there's a way to do that without you can do anti-Markovnikov addition if you add in some peroxide. So we're gonna do HBr. Let's say HI, and then let's do and hydrogen peroxide, and that'll give us the anti-Markovnikov product. And we're gonna say that because of the methyl group being here, that that's gonna happen like so, right? So the eyes, that's gonna add from the opposite face. And then we can take that and then treat it with, again, this vinyl lithium thing is pervasive. Treat that with that, and then that should couple, well, it should react in a SN2 type fashion to give me that. Actually, let me go back, because this should be the opposite. It should be wedged, right? Because the iodine is going to come from the opposite face of this pre-existing stereo center. But when you do the SN2 type reaction, it's going to reverse it, because the stereochemistry at that center should get inverted. But where would we get this from? And then we'll stop here. Where we get this from? What do you think? Based on what we've already seen. Right, there's a couple of ways we can get that, actually. We could get it from some Alkyne technology, like we've already seen, or we could get it from here. I think we talked about, didn't we talk about the Bamford-Stevens reaction already? Yeah, 1, 2, 3, yeah. We could start with that and then treat it with so we could do Bamford-Stevens to get there. Right, so we did the Bamford-Stevens reaction on propionaldehyde. We could get there and convert that into a vinyl lithium. That's one of the more ubiquitous ways to generate vinyl lithiums. So we did the Vidic with acetone. So this plus this, that's going to give us that. And then if we take that and do anti-Markovnikov iodination, we get this. And then if we treat that with that vinyl lithium, then we're able to get this part up here. And we're banking on the pre-existing methyl group right here to control the stereochemistry. All right, any questions about that one? All right, we'll stop here, and then we'll work on number 2 on Monday. And then I think we only got, when is the end of the semester? Is it May 1st, May something?
It's May something.
Check
I'll
again.
look real quick.
I thought it was the 14th. I have to check again though.
May 14th. Okay, that sounds about right. Because I know graduation is like it's the following, it's not Mother's Day weekend, it's the following weekend. So yeah. All right. So we got time. I'm gonna have to see what's left on the syllabus that we need to hit. And then I'm thinking about as far as exams are